next speaker is joining us from Clear Intelligence. Clear Intelligence is a leading data and analytics consulting firm. They provide solutions by means of IoT, blockchain, AI, machine learning, personality insights, and more. Our presenter from Clear Intelligence currently holds the title of Chief Innovation Officer. Prior to his role at Clear Intelligence, he led client success for global strategic accounts at SAP and served as the SVP and CIO for Dean Foods. Today, he will be presenting on Art of the Possible using AI-based vision and acoustic solutions. Please welcome with a warm round of applause, Brian Murphy of Clear Intelligence.
Thanks, guys. So the first thing I like to kind of start off with is we're going to go through an agenda. We're going to show you some use cases. We're going to talk about what is vision. I'm going to give you some examples and things like that. But the first thing is just some interesting things is you're probably already using it today. You just maybe don't know you're using it. So did anyone sign into an iPhone today with either the fingerprint or the face? You used AI vision. If you drove a Tesla anywhere, right, you're using vision. All right, so people don't actually know. I'm sure somebody's going to put their hand up and tell me they were on Snapchat today with one of those filters, right? It's AI vision based. It's using that to recognize face and place things out there. Interesting fact was computer vision was actually started by MIT in 1966. And for those of you notice I have a little bit of a different accent. That's the last time England won the World Cup in what we call football, you guys call soccer, right? So, although I have to say now it's soccer as well because I'm American as well. So I get confused between those two. And in some areas, vision is actually proven to be more effective than humans, particularly in medical. So, for example, in chest x-rays where they're identifying either growths or anomalies, they've proved that the computer vision, when it's trained correctly, can identify things that most 9 out of 15 technicians will miss. So actually, computer vision can not just be as effective, it can actually be more effective, and we'll talk about that too. And strangely, agriculture is actually an industry that's using it probably a lot more than some, right? Primarily because of the scale of agriculture. They use a lot of satellite imagery as well, so it's not just limited to local imagery. It uses satellite imagery, and they do things like calculate stress on crops to decide whether the crops are healthy or whether the crops need water in, and they'll drive some value out of that. The other thing is speed. You can process large amounts of data, right, that humans just can't. They can do, but not at scale. So an example about that is one of the police departments processed something like 48,000 license plates within 48 hours with a single computer, and they made money from it because they issued citations and things like that, but a human couldn't go through 48,000 license plates in 48 hours. So it can be at scale. And a lot of the reasons why you're seeing it now, you think back 1966, well, what's been going on? The problem is computer vision is highly intensive when you train models on the computer itself. But what's happened in the last couple of years is GPUs have come up, so the processing units to actually do the model training, I've come to the point where now I can generate a model much faster, I can retrain it much faster, and now it becomes more effective. Because the actual power is in the training. You can then deploy it, and if you come to our stand, you'll see us deploy learning models to a Raspberry Pi. I mean, it doesn't need a lot of compute power to actually execute the vision model. It needs a lot of power to train it. So that's why you're seeing it a lot more. So what is it? So if you sign onto your Apple phone, think about it, what I tell people is, think about it like it's not the eyes or ears that are taking it in, it's the brain that's processing it. So all computer vision is the ability to interpret those signals and make sense of them, identify objects, right? You think about, I always use the analogy, you think about a child. So a child in the first couple of years, I don't remember the stats completely, but they see an image, the eye processes an image about every 200 milliseconds. So by the time the child is about 2 to 3 years old, they've seen millions of images. Nobody taught a child to see, right? What they taught a child was to interpret. That's the machine learning. It's not the eye, it's not the ability to see, it's the ability to process the imagery and understand it. That's what computer vision is. And it's a subset, for those that know, if you think about machine learning, deep learning, it's a subset of that component. So it uses the same stuff, it uses different models, but it's the same concepts as machine learning. It's just a deep learning algorithm below that. So how does it work? So we always use the analogy in computer vision is if you can take a child or an adult, depending on your environment, and teach them to look for something. So if you think about it, we have an example on the stand, which is just a pen. First time a child sees an Expo pen colored green, they don't know what that is. But you tell a child, look, let me show you this image embedded in the image is a section, and that's the pen. And by the way, here's a pen with a missing cap. Here's a pen that's green in color, blue in color. So you train a child to do that. Anything you can visually train them by showing them, we can train a computer to do exactly the same. Now, the tricks come in when you've got to show what's good and what's not good, right? So if I'm doing defect detection, the trick in the model, for example, if something's missing, I can't see it. So how do I tell you something's missing when it's not there to highlight? So you have to think reverse. You've got to figure out, how do I show you what good is? And then when something's not good and it looks a little different, I'll now tell you what's missing. So this whole concept is really about how we train. And the key with training is, with any machine learning training, everybody will tell you, the key is data. Data is king. And if you've got bad data, guess what? The model's bad. Or if you've got biased data, the model is biased. Right? So part of the key in here is making sure you got a good set of data. So an example of that is, so working with a client, and they do on the railroads, they do tanks, and certain of those tanks that contain caustic or hazardous materials have to be 100% weld inspected. So they have to X-ray every single part of that weld in that machine. And guess what happens? The person comes along and he takes it. By the way, it's not digital right now, it's film. They put the film up on the white box, like the doctors do, and they go and they look for defects. So they got a good data set because they got all of this film. We can digitize that film, process it in, and then we can actually train a model on those images because they're good images. They're images of all the actual welds, and they've already flagged those images with the defects. So you got to have a good data set. Or you go out and you create your data set. Now, one of the beauties around this is we can go out and take limited data sets and do what we call data augmentation. So if you think about the example we have out there, we probably took 15 pictures of different pens. And then we went out and we said, now augment that data. So from 15 pictures, we created 600 pictures. And what we do is we rotate them, we blur them, we sharpen them, we decolorize them, we do different things with the images that generate new images. Same image, it's just changed. And that way we give the model something to learn from. So that's kind of like the whole approach here. And then we iterate that. So we train a model, and we get more images, and we use transfer learning. We use the model to tag them, and then we correct its mistakes, and we just go through that cycle. So it's not that complex. It's actually, as long as you got an SME who knows what to look for in a defect, or in, you got somebody who knows when they look at a leaf in a crop, whether that leaf is bad or whatever, it's fairly easy to do. What are some of the example use cases? So people kind of go, yeah, I get it. I understand vision. How do I use it? So a couple of areas you'll see a lot going on. I mean, there's a lot more than this. These are just some of the ones that I think are relevant across industries a lot of times. But people's safety. So personal protective equipment. For those of you that have worked on either construction sites or in manufacturing facilities or whatever it may be, in labs and things like that, you have to wear a certain, so sometimes it's the hard hat and glasses. Other times it's, it's certain glasses if you're in hazardous areas, or it's white vests or boots that you need to wear for protection. So we can actually train it to look and say, if I see somebody, I identify that they're a person, not an object, but they're a person. are they wearing, and I can train the model, are they wearing what they need to wear? And if they're not, what should I do? I'll alert somebody, right? I can't stop them, unless I got a robot, but I can certainly go and alert the manager, hey, somebody's not wearing a hard hat, or somebody's not wearing a safety vest. Hazardous area monitoring. So I used to work in a company that made ice cream. And they used a lot of ammonia. So they had ammonia refrigeration plants. Well, you go in there, they're hazardous. You have to be trained to go in there. You have to be trained to work on that equipment. And if there's an ammonia leak, you have to evacuate the factory. But to be able to monitor who goes in those hazardous areas, and hazardous can be defined as, well, it's a dangerous area from a chemical or hazardous material point of view. It could be, a specific area where you don't want people staying. I worked in a company that had a large logistics fleet. And unfortunately, once a year, somebody died. And that's not a good thing, right? And the last one I was there was a supervisor, and he was at the loading dock. He's leaning on the loading dock, and he's on his phone. He's listening. He's having a conversation on his phone. So he didn't hear the truck reversing up, right? And the truck reversed into him, put him between that, because, he couldn't hear the truck and the driver couldn't see, right? Well, I'll show you in a little bit a video of a solution that we could deploy that would have averted that at the time. We didn't know about it. Safe machine operation enforcement. I used to run production lines back in my Colgate days, and I always said my engineering maintenance people were always the most effective at bypassing safety controls. They could figure out how to open, the people who've been in manufacturing, they could figure out how to open the door and keep that machine running, defeat the interlock, stuff like that. You can train it, here's a machine running, here's a gate open, a door open, or anything else, stop. Don't even let the machine run, right? Equipment operation and policy. Are people operating equipment that they're trained to operate? Or do they need, so are they on a forklift truck? They don't have a forklift truck driving license, right? They've not been trained to drive a forklift truck. So can I enforce policies like that? Here's an area where you'll see a demo is quality and efficiency. We all get situations where you get damaged product or missing product, mislabeled product and things like that. We were just talking to somebody at lunch around that. And so can I look, our demo will show you, can I look and see something missing from a product? Can I look and see if a product is damaged in some way? It's missing either a component that I need to finish it, it's damaged, the labels, or I've got the wrong, if you ever look at milk, if you look at the cap label, always represents the fat level, right? So light blue is typically skim, right? Well, if you put the wrong one on the wrong one, it's a problem, right? So you can do things like detection like that, it's visual. Operation, so if you run an operation, we're working on one that, so two things. One is, can I look at welding both from a visual and an audio point of view? So this one, they do more welding than the shipyards. So the biggest welder in the US. But they have to inspect 100% their welds. So somebody goes along with a torch and climbs underneath and looks at all the welds and has to be able to inspect that weld. Then they do 100% inspection on a container to make sure that the x-rays on that one for hazardous is there. Can I go and inspect that in audio? A great use case is with sound. So if you take automotive welding, which is slightly different than linear welding. If you take automotive, it's spot welding typically. Well, what you can do is when you spot weld, you can detect the sound of the spot weld. And what they've seen is with 95% accuracy, I can tell you whether that weld's a good weld or not based on the sound of the operation. Not the picture of it, but the sound of the actual operation. If it doesn't sound right, the weld is not good, right? So it's not just visual, it's audio too. And then can I detect things like overfilling? Can I detect product coming out? Can I detect stuff that's going on, basically inefficient operations out there. Equipment inspection, where we see a lot of this is where you got large areas to cover. It's very difficult. If I got to go and inspect power lines, I can't get up there and inspect them. If I got to go and look at deforestation around the power lines, do I need to go and cut things down? It's a lot of ground to cover. And I can do that much more efficiently either via drones or equipment attached to a vehicle. So if you take a rail track, for example, I can put equipment on, or even a road, and I can drive down it, the track or the road, and do visual inspection to know, do I have potholes, do I have cracks, do I have missing ties on the railway that I need to go and fix? So we see, particularly where you've got large amounts of inspection. We're working with a client that does, as a railroad, as a piece of equipment goes through the yard, we're looking, we detect with a camera, we take a snapshot of, primarily right now it's the wheel, right? So the wheel assembly, and there's a couple of things can go wrong with the wheel assembly. You can have a crack, you need to pull out off the line and repair the crack if it's significant enough. You have a broken spring, there's springs in them, and sometimes over time, just like a car probably spring, it'll break, right? And then you've got connectors, bolts and stuff that can just wear loose, break, rust away, et cetera. So from that, as everything goes past, we detect which is the, every one of them has a unique ID on. So detect the ID, take pictures of the wheels, and then alert them to say, hey, either this truck needs to come off, or if it's going in for maintenance, here's the 3 things that you need to look at as well. So it doesn't need to come off, it's not critical, it's not a regulatory issue, but it certainly is a maintenance issue. So here, I've got a couple of videos, I think you get this deck, but these are useful. So the top left here is what we call intrusion detection. So this is the one where I mentioned the person at the dock. If we'd have had something like this, we can see somebody, they'll walk in, it doesn't alert that they're heading that direction, but when they're in a certain zone, we can either detect they're in the zone, or we can detect how long they're in the zone for out there. So you'll see the person walking in as soon as they're in an area. So that area would be, for example, a loading bay, or it could be a hazardous area where you don't want anyone in. The second one is not looking at motion, it's looking at the direction the body is. So it's saying, if you're standing up, I'm okay, but if I see you down, and you know, typically you're injured. Now, I used to work in manufacturing, sometimes that meant they were just asleep, right, out there. But you could certainly see that and say, oh, you're down, now alert me. Don't alert me if you're just walking across the road. Alert me when you're in a dangerous position. Space detection, you know, where you're looking for, we've all tried to find that car parking space, right? So cities are starting to look at how do they do that without having to put sensors all over the place, right? The bottom left one is what we call object left. So you think about somebody, you'll see somebody walk in, I think if it runs, they'll walk in, they'll drop a bag. It's a black bag on a black bench. I'm not sure that's playing, but you'll see them, where are we? See if I can. No. I can't get the mouse pointer. But there'll be a person, and what it does is it sees an object left that wasn't there before. The middle one is object taken. So if there's an object somewhere. So if you think about this, probably the most famous one of this is Amazon Go, right? You think about it. Go in a store, and all they're doing is object taken. Now, they're doing the reverse of that. If I put the object back, and it's a net, right? So if you think about the combination of them two, one is object taken, the other one is object left. And they're netting that out. And then the bottom right is queue detection, is another example. I can count the number of people, I can count how long those people are in the queue, so I can count the process and cycle time of those queues. So these are just some examples, I mean, simple examples, but you can see how powerful they can be going through. And then it doesn't have to be, line of sight has a problem. You know, I went into a customer and he said, oh, I want to use drones in my warehouse. To do what? And they were like, well, you know, to do inventory. I said, okay, walk me through your warehouse. Is your warehouse stacked? Is it single rack with single products? Or is it, you know, pushback racking where I've got products and as I take one, the rack comes down? Oh, it's that one. No, you can't do it. Because unless you get line of sight, I can't put a camera on a drone and see behind a pallet and see behind another pallet, right? So, but what you can do is, there's another one called LiDAR. So if you ever get caught by the police and they've got you for speeding, that's typically LiDAR. And so it's a very good for ranging, it knows speed, and it can calculate a lot of things. But it also does a lot of bouncing around the room. So you can actually take it, so this image is single point image. So it's a single camera, but yet I've got an image that's 3-dimensional because it's bound. Now it's not as well defined as you can see as a visual image, but what you can do is you can overlay a 3-dimensional over a visual image, and get much more precise between the two. And you can use this, I mean, this one's just showing you the demo, but you can, actually, if you know, it's in California. But if you use that, you can use it for things like pallet volume estimation. So I can take pictures of pallets, and they may not be full pallets, they may be part pallets. But from volume estimation, I can figure out, okay, that's the volume, how many boxes are on that pallet. So I can do things with 3-dimension that I can't do in 2-dimension. Still, it's a vision. It's just a different form of vision. It's not, normal spectrum. It's a different spectrum. And it's using computers to figure out where's the bouncing. So think about it like sonar, right? It's kind of like a sonar type of thing. But companies will use this to see what's going on in a much larger area. This can save. If I put this in a large car park, I have to put vision cameras, and I put LiDAR in place. I can save they're more expensive, but I can save about 70% of the camera coverage, because they can go much further. They can do things that line of sight can't do. So if I don't have line of sight, I got to put another camera somewhere else. If you think about a factory, I'd have to put them all around because I got equipment and pipe work and everything. With this, you can use much fewer cameras. So this is this is our framework. So we built this framework because the learning models are all, if you go through, anybody says it, that, our model is unique. They're all based on open source. For those of you who know, it's all TensorFlow based, and it's all of those models, and then they use different model formats, faster RCNNs. You'll hear them talk about these things. They're all open source models. The biggest trick is the data, the speed you can train at, and then the framework you can deploy on. And we realized that not every customer is the same, and not every problem is the same. So we had to build a framework. So what we said is, we need to source from multiple sources. So we can source from, if you got a DVR system, we can tap into that as long as we can read it through it digitally. We can take a standard feed off a CCTV camera. We even had that running in our office for a while, and the employees were like, "What are you videoing?" We're just using it to count, recognize, and then we're creating a welcome app in our office just to make it fun, right? Smart glasses. So if you get into picking operations where you're mobile, so you're the lens, right? You can use glasses to be able to not only detect things, but then show you. So, you should pick from this bin, right? Versus, and then did you pick? I only have to look at it and know what I picked, right? So you'll see smart glasses, typical phone, whether it be iPhone, Android. If you come to our booth, we have an iPhone app there. We just use that to snap the picture, and then on the computer screen, actually alerts us what's going on. So we can go from the phone to the computer. And then a microphone, so depending on whether you're using audio or visual. So we had to build a framework to be able to ingest any of them. And then we realized you got to have an architecture that meets sometimes, one, the customer's needs, and two, the problem needs. So what do we mean by that? So first of all, some customers, I'm cloud only. I don't want to put any hardware in. I want to do everything on the cloud. So we can't do that. The only problem with that is if you've got a problem that needs fast reaction at the point of problem. So if I'm detecting a defective product, I don't want to wait for that to come back. I need to know now whether that product's defective or not. Because I may want to kick it off the line. I may want to stop the machine. If I've got a safety issue, I may want to shut it down, right? So I don't want any latency. So then we go into what we call edge endpoint. So we've got an example out there that uses a real face detection, and it's called a Jetson. It's basically a Raspberry Pi on steroids, for those that know those things. But it's a piece of equipment that costs $70, right? And I can stick it at the endpoint, and it's enough to process the model and be able to do my detection at the point. And then the server endpoint. So if I've got a lot of data and the latency's not as bad, I can put it in my data center and I can do all of my work there. So we have another one that calls our data center in Dallas and takes an image here, sends it back to Dallas, processes it, and sends it back to us and it tells us what it sees. So we've got examples of these going on. And then we said we need an alerting framework. So we built an alerting framework, more subscription-based. So what do you want me to do when I find what you asked me to find? So if I've got a safety issue, I probably want to text the supervisor, right? I don't want to put it in a database and let somebody go and detect it and have a conversation afterwards. It's safety. I need to deal with it here and now, right? If it's something that, you know, I can make a phone call. So I can turn the issue into a phone call and make an automated phone call, and then from text to voice, I process that and I can alert you. Do I want to stop machinery, digital out? Do I just want to report on it? Do I want to take the data and tell me, hey, who went into that hazardous area in the last 7 days? Well, you know, we had a customer that has you know, an area where they have to detect for customs, they have to detect who goes into that area and who doesn't, right? Well, right now, you know, when we went to them, they were like, well, we just have the video, and if anyone asks questions, we kind of go back, and we have to go back through all of the video, right? To detect, you know, somebody may not go in that area for 2 hours, but we have to go through the video and get it. There was you know, another one is a police force was using, I think it's Seattle. They get something like, I don't remember, it's something like 20,000 requests for evidence. And what they have to do with that video is they have to go through the video and they blur out manually people's faces who aren't the subject of the investigation for privacy reasons. So now they can go through and say, here's who I'm interested in. Now go and process the video and blur every other face you see out because I can detect faces, right? So it's things like that that we can go, do I want an immediate alert? Do I want a batch alert? Or do I just want to go and pull on demand, right, and see what I've got, data and analytics? So am I doing object analytics, defect analytics? Am I controlling the machine? Or do I want anywhere, any device, right? Do I want to be able to see it on my phone? Do I want a tablet? Do I want to call somebody and handle it like that? So this for us was the real kind of, think about it like this is the glue. Everything else is open source. You got your products. The Power AI Vision, the product that trains the model, you know, that's the big engine for us. That's the one that builds us the model. But then this is what executes the model. Because once you've trained it, you take it out, you deploy it wherever you want, on the edge, in the cloud, wherever. The workhorse is that first one. But this is the execution framework out there. So what we tried to do is give everyone, doesn't matter what you got, we can deploy it either within your architecture or we can deploy it, you know, based on your specific needs, right? And then how to think about it, right? So, you know, some of the things we tell people is you have tasks that are reliant on. You know, you have tasks where you have a lot of people or people that are tied up looking at something to determine whether it's good or bad or whether it's a safety issue or not. So that's an efficiency and effectiveness play. Are these using knowledge that's embedded? I always call it tribal knowledge. That, you know, if you lose that knowledge, it's gone. It's not embedded somewhere. The beauty about the computer, you know, I also use it is I actually had a conversation here and somebody told me, oh yeah, you mean don't buy a car that was made on a Monday or a Friday. I never knew that one. And they said because on a union shop, a Monday or a Friday, it was like everyone came in, had a bad week, didn't want to do stuff, wanted to leave on a Friday, so you got more quality issues on Monday and Fridays. Well, the advantage about the computer is it doesn't care. It can scale, right? And it doesn't want to sleep, right? And more importantly, it doesn't make a judgment. It decides what you want it to. It doesn't wake up on a Monday morning and say, you know what, I'm not going to be as efficient today. It's just going to do what you tell it to do out there. And do you have a business opportunity to offer a new way to experience a product? You'll start to see all of these, you know, some products, I'll give you some examples outside of what we do, just so you get a bigger picture, because it's not just about what we do. It's about how you can use it. Anyone ever seen the Olay skin product that uses AI? So they have a product, I'm sure men and women use it. They put it to the face, detects the face, guesses their age, puts a skin type on them, and makes recommendations to them for products. When they put that out, 88% of the people who used it bought a product. AI Vision, their own products. They didn't change the products. What they changed was the way the consumer experienced how to determine their products, and having to go in a store, and you would go in the store and you would get somebody who's an expert and they'd look at you and they give you the advice, right? Right? But they created one. Wendy's created one in China that you go in and through facial recognition, you have an account, they link you to the account and they let you pay with your face. You don't do anything else. Go to the machine, you order what you want, it sees your face, debits your account, and you're done and gone out there. So those are competitive advantage. It differentiates. I was really interested in TGI Fridays. It changes the consumer experience that he talked about and makes them, oh, now I'm going to do things. There was another one I looked at that said, hey, this is a really interesting one. So it's an online shoe company. Well, what's the problem with online shoes? You don't know, right, until you get them, whether you like them or not. So people go into the stores, and they can feel them, put them on. So this one, actually, you pick the shoe, you shine it, you point it at your foot, and it detects your foot, and then it overlays the shoe onto your foot, so you can actually see what it looks like through the phone and app. Those are changing the experience of how people, and they're all AI vision-based, right? The biggest and last thing is, where does it impact your P&L? I think somebody said, don't do it because it's a PR and a shiny object. If it doesn't hit this business case potential, ask yourself why you're doing it. Even if it's a PR thing, then you better make sure that you're driving you're doing something with it that is an outcome base that hits your P&L, right? So is it affecting the bottom line? Is it saving you people and money and making the process more efficient? That's the rail car manufacturer. If they can make quality inspection faster, they can get more throughput, because their problem is they don't have enough capacity to make all the orders, and they're always moving stuff around. They can make money, because then now they spread their fixed costs over the larger number of volume. And then is it top line? So are they operating a difference? Are they doing something different and generating top line growth? So some key questions and challenges as we've gone through this. So one is, if you've got existing data sets, figure out and go and put your feet in there, because you got the data, right? Companies are buying companies not for the company, but for data, and that's valuable. So if I've got a load of data sets, this company has a load of, it's film-based, but I'm going to take the x-rays. What's the throughput of testing? I got to ask myself, how much have I got to do so I know, can I handle that volume? Can I do it? Is it a scaling issue or whatever? Do you need immediate response or batch? Because if you don't need immediate response, you can do a lot of things post-processing that can be, now you just need the answer, you need the analytics. And then I'll show you this, but we always do high-level estimate, complexity, and business impact. When we come in, you'll see the graph in a second. We want to know what's the complexity and what's the value, because if you're working on something that's highly complex and doesn't have a lot of value, ask yourself why you're working on it, all right? It's noise. And the big thing is, think about, do I have a problem today that you solve today inefficiently or ineffectively? Do I throw people at it? Do I slow my processes down? So I'm doing it, but it's really inefficient and effective. That business case is simple, right? You can do the math on it. If I turn around and I'm doing it inefficiently, and I can take that, I got 30 people doing this, and I can take it to 2, it's great, right? I can do the math. What we do at Clear is we use a process, so we don't come in and go, we do have some products will come in and go, hey, here you go. What we want to know is, what's your problem? So the first thing we do is around discovery. So you'll get this to take away, but we call it did it, right? And we call it did it for a reason, because after you've done it, you've did it, right? Out there. I forget the movie that did that, but he put his hands up and went, did it. But really it's about discover, where we look and we solve the problem, not the symptom. We want to know what the problem is, not what the symptom is. We ideate. We don't just say we've got a hammer, therefore it's a nail, let's go and hit the nail on the head. We want to know, what are the options for you? So the drone in the warehouse, could I put a drone in the warehouse? Yeah, I could. But I know it's not going to work, so I want to ideate. I know what the problem is. Now I want to ideate around solutions and the potential to solve it. Then we develop, we implement, but then the last thing for us is transform. What we want to know is, how do you ensure you get to the P&L value, and how do you ensure that you adopt it? Because the biggest problem with a lot of projects is they don't get adopted, and you don't expand them, scale them, and that's where the money is for us. And then I'll leave you at this. So what we want to do is we come in, business value and impact. We don't want to operate in the bottom left. Neither should you. So I used to call it, if you've ever heard, the tyranny of incrementalism. If you're doing a lot of things that have a little impact, you're making noise. You're not doing anything else. What we want to do is look at big impact. Ideally, we want complexity to be low, quick wins, but we also want to make sure that, hey, if you've got something that's got a lot of impact, it's a no-brainer, right? And so we look at that and say, hey, you have 6 problems. Which one should you focus in on? That's what we want to know. If you can focus in on the low complex with the, hey, it should be less complex down there. I always get that mixed up. But less complex, high value, let's go after them. Let's put them in, but let's have some quick wins along the way. Let's build an MVP, let's go improve the value out, and then scale, right? And that's what we're doing with the, we're saying, hey, we can help you with X-rays. Now we're going on and helping them with the next level. So with that, any questions? Go ahead.
It's very interesting. Thank you for the information. So I'm in the transportation business. So I saw a couple applications that we could look into: the parking spaces, wrong way driver detection, things like that. So a couple questions. One, you mentioned, right, the most intense phase is really the tuning, gathering the data in the learning process. So an average, a project like that, what would it look like? Are we talking about a month? Are we talking about 6 months? Are we talking about a year? In knowing what you guys can do and the multiple applications that we could use it for, can we combine all those, or do you treat those as separate entities, separate projects, separate even hardware to resolve those problems, right?
So let me answer the first one. So in terms of time, so one, it'll depend on the complexity of what you're trying to analyze, right, and the number of situations you're trying to analyze. But give you an example. You go out and look at the pen model that we did. I created that model in 2 hours. Now, it's a very simplistic model. It's not complex, but we did it for demo because it looks like, oh, I can see defect, I can see recognition. And so, but typically, if you've got the data, it can take about, less than a month to train. If you've got to go and collect the data, then it can take a lot longer because you've got to find good and bad. And if some of the bad is only infrequent, it takes you longer to get enough samples of that. Does that make sense? So it's not intensive 24 hours a day, but you've got to give yourself time to get the data. It's not the effort. It's if this problem only happens every 5 days, then I got a lot of time to run before I got enough samples. It typically takes about 1,000 images to train a model well, right? At least 1,000 images. Now you can augment data, but if you want really, really good, that's 1,000 fresh images, and then you turn that 1,000 to 20,000, right? The second part, I'm not sure I completely, but you said, do we treat each one of them in the deployment as separate, or can I reuse components of it?
Right. So, for example, we want to do parking space count, so we can polish that for our users, but at the same time, we want to do wrong way driver detection at our ramps, and maybe some other application where we can use image analysis software.
So all of the same, it's using all the same base technology, and if the cameras can be used for multiple purposes, we don't, it's like, if the camera's pointing there and I want to detect 3 things, you can detect 3 things with the same camera. It's not, I got to put 3 cameras in, I got to put 3 servers in. I can detect multiple things within the same framework and the same hardware, right? So I get leverage. For us, it's just, do you want to run them as 2 projects, or do you want to run them in, do you want to run them in parallel, or do you want to, that's your call, not ours. But the framework's the same framework, right? And you get to leverage it. And because what we found with customers, once they identify one thing, they go, you solved this problem for me. I got 7 other things that I want to solve, right, that I know. Prove this one to me, and I'm going to keep you busy, right? And because now they've realized I've put the base in and they're off and running. So they already know there's 6 or 7 things, just like you do.
Thank you.
Hopefully, you come to the stand. We can give you some demos if you're interested and want to see it a little bit more than beyond the videos we showed. And I think the deck goes out, so I'm hoping that's a big deck because it's got embedded videos in it, but we'll figure that out. All right.
Let's give Brian a warm round of applause. Great presentation.